All right, guys. So yeah, where are we? I think Wednesday last week we well, of course we discussed frequency tables and then how to make a histogram, and then we're trying to describe the shape of histograms, right? So I'm gonna just remind you the different kind of shapes of histograms, and then I'm gonna have like at least one example. Okay, so let me just remind you. So this is again, we are still in the same section. So this is section um, 2.1, right? Frequency tables and histograms. Right. So just to remind you, so if you want to display frequency or relative frequency, then we can use histograms, right? So we use histograms to display frequency or relative frequency. Okay, and then so for example, so for example, so an histogram would be something like this here. So on the horizontal axis, we said we're going to have our classes boundaries on the horizontal axis. Right, and then on the vertical axis, we're going to have either frequency or relative frequency, right? It depends on the question, right, or on the problem. So let's say this is your frequency, okay, or relative frequency, and then so you have your histogram, right? So we have like you have your classes boundaries, and then each frequency is represented by like a rectangle, right? So you have like you have like bunch of rectangles, etc. Anyway, so now we're gonna describe the our histogram, and we're gonna try to get some information from the histogram, right? That's our goal, right? So to to represent the data and get some information from the data. So to describe, so we have to describe the histogram. So we have different kind of shapes. So we have the following shapes. So we said so first. So we have histograms with a regular or uniform. So this is one. So regular or uniform shape. Okay, and so in this case, I mean, all the classes, they have more or less the same frequency, right? So all classes have more or less the same frequency. So all of the rectangles, they would have like the same height, right? More or less. So you're gonna have like something which looks like, so example, so you're gonna have a histogram which looks like something like this here. So right, so this is what I call a uniform or regular histogram. Right. Now next we have the skewed left or right. Right? So this is when one end has more or less the higher frequency classes. So one end. So this is when one end has more or less the higher frequency. So one end has higher frequency classes, right? So then your histogram, so either it's a skewed left or right. So for example, this one here, so this histogram would be skewed right. So this one here, it's a skewed right, because here on the right side here, you have like the two classes with the highest frequencies, right? So it's a skewed right. Now, if you have something which looks like, like on the left side, you have like the classes. So let's say you have something like this here. Okay, so in this case, as you can see on the left side, you have the classes with the highest frequencies. Okay, so this would be a skewed left histogram. Okay, and yeah, one more shape would be the so shape number 3. Right, the mount shaped symmetrical, right? So it's going to be symmetric about the center. So this is mount shape symmetrical, right? So in this case, your histogram is going to be, symmetric about the center. So about the center. So it's like, like in the middle, you're going to have like a class here in the middle, and then so the classes like on the right side, they're gonna look like exactly the same like the classes on the left side, right? So it's something like this here, right? So so as you can see, for example, this blue one here looks exactly has the same frequency as this one, right? Then the next one right here, this one looks exactly has the same frequency or same height as this one here, and then you have these two classes on the left and on the right, and they have the same, they have the same frequency, the same height. So then, and so the class in the middle, that's your center, right? This is like, so the class in the middle, this one here. So this is like the center of your histogram. So this is like the center, like, in the middle of your histogram. This is your center, right? So it's a symmetric about the center of the histogram. All right, so let's have an example. Okay, let's have an explicit example. So what I'm gonna do, I'm gonna use an example we had like I think last week. The speeds of the cars on the highway. I mean, we made the frequency table, so we know we know the classes boundaries, and we know the frequencies. So so let's do an example, and we're gonna try to describe the shape of the histogram. Okay, so example. This is the example with the speeds. So the speed of 24 cars on a highway. So we had this example last week, right? I mean, I won't write down again the data, the speed, so the data values, right? So we had this example last week. So anyway, so the goal here would be to describe last week. So what I'm gonna do now, I'm gonna try to describe the histogram. So the shape of the histogram. Well, first, of course, I'm gonna need, we need, classes, boundaries, and frequencies. So I'm gonna just remind you here very quickly. So in this example, I think we had, I think we had like 6 classes, right? So I'm gonna just write down here. Oops, of course. Okay. Yeah, so I'm gonna just write down here the classes boundaries. So in this example, we had 6 classes. So 6 classes. Okay, if you check your notes last week, you can find all the computations. Anyway, so classes boundaries, and then I'm gonna use the histogram to display the frequency. So here's the frequency, and we have like frequency. So we have the following values. Like 42.5, 50.5, then 50.5. I think the width was like an 8. So this is like a 58.5. So 58.5, and then 66.5, 66.5. So this is our classes boundaries. And again, these numbers, they are from the example we had last week. So 66.5 to 74, 4 classes. So 74.5 to 82.5, and then 82.5 to plus 8. This is 90.5. So we had 6 classes. That's our classes boundaries, and then the frequencies we have like 1, 0, 1, if I'm not mistaken, and then 6 and like 8, 8, right? So this is the numbers we have. This is our classes boundaries and frequency. Okay. So now let me graph. So I'm gonna graph the histogram and describe his shape, right? Graph histogram and describe its shape. So for the graph, for the histogram, the classes boundaries. So you have your horizontal axis, right? You have your classes boundaries, 42.5, 50.5, 58.5, 66.5, 74, 74, yes, 0.5. And then I'm gonna need more space, I guess, here. So this is 82.5 and then 90.5, right? So on the horizontal axis, we have our classes boundaries. So this is our classes boundaries, and then on the vertical axis, right, we're gonna have our frequency. Now, again, the intersection of the horizontal and the vertical axis, that will be 0. So here's like my 0, and then we're gonna go up. So 0, then we're gonna have 1 unit, 2 units. So we're gonna need 1 unit, 6, and we're gonna need 8, right? So 3, 4, 5, 6, 7, and 8. All right. So then first class. Frequency of the first class is 1. So this is my first class. It's from 42.5 to 50.5. That's my first class. So this interval represents the first class. And so the frequency is 1. So the height or the width of my rectangle is going to be 1. So here we're going to go up to 1. So you can see here. And so this is the frequency. This rectangle represent, this blue rectangle represent frequency of my first class. Now, second class is 0. So as you can see, some classes they can have 0 as frequency, right? So like in the exercise number 2 in the homework, you're probably gonna have like some classes with 0 frequency. Okay, so it can happen. Now, so this is just my. So this is supposed to be my second class with 0 frequency. Now my third, so it's frequency is 0, so we don't draw any rectangle. Okay, there is no rectangle. It's just the interval, right? Now next class, again, we're gonna have 1 as frequency. So this is my third class was with 1 as frequency. Fourth, it's 6. The frequency is 6. So this is my fourth class, fourth interval. The frequency is 6. So we're gonna go up to 6 units. So you can see here. Right, and then the last 2 classes has 8 as frequency, right? So the last 2 classes, like the fifth has 8 as frequency, so we need to go up to 8 here. Okay, and the same thing for the sixth class, right? So it's also 8. So here we're gonna go up to 8. All right, guys. Any guess what will be the shape of this histogram?
Skew to the right.
Skew to the right, absolutely, very good. So as you can see, the classes with the highest frequencies, they are on the right side, right? So very good. So so this is my classes. So I have 2 classes here with the highest frequencies. The highest frequency, right? So in this case, this is skewed to the right. Okay, because it's on the right side here, we have our classes with the highest frequency. Does this example make sense to you guys?
Yes.
So, yeah. So in general, your
Yes.
histogram is gonna look like either skewed to the right or to the left. It's gonna be like uniform, like all the classes they have more or less same same frequencies, or it's gonna be like symmetric about the center. All right. So this is skewed to the right. I mean, we can do more examples, I guess, or yeah, no, probably we don't have time. So I mean, I don't think this is the shape of the histogram. I don't think it's really hard. As I said, you can just compare. You know, we have only like 3 shapes, right? Different shapes, and all right. So let me just say one more thing here, guys. There are sometimes there are like gaps in your histogram. Okay. So let me make this following remark. So like in the exercise number 2 in the homework, you have like, you have your classes, first classes, but then you have like 3 or I don't know, 3 or 2 classes with 0 frequency. And then the last class like has 1 as frequency, right? So, if you have gaps, so gaps in histograms, okay, they may suggest what I call outliers. Okay, so what do I mean by outliers? I mean like exceptional exceptional values. So the outliers, this is like a kind of some exceptional, exceptional values. So those values are like very different from the other values. Okay. Exceptional values. In other words, so this is like values are different, very different. From other values. For example, okay, let's do an example. Like let's say you have the salaries of in the salaries in a company, right? In the small, let's say you have like a small company, and then you have the salaries of the employees, right? So so example, so we have like let's say salaries. And let's say you have like a small business here. So a small company. Okay. And then let's say, for example, we have, so let's say we have the following histogram. Okay. So you have your class's boundaries. So the class's boundaries, of course, they're supposed to represent like the salaries, right? So this is class's boundaries. Right, and then you have the frequency here. And then, so let's say you have the following, let's say that we have like the following histogram. Okay, so we have all these classes. All right, and then let's say you have like two classes with the 0 frequency. Okay, and then last class is like, has like 1 as a frequency, right? So it's like we have this last class here, the frequency of the last class here, it's a very small frequency, right? Let's say this is just 1 here, okay? Etc. Okay? So, so in this histogram, as you can see, there's like a gap, right? Between, the first classes, the first classes here, they have more or less the same frequency, right? The first classes here, okay? And then you have this gap, okay? And then you have this, last class with frequency equal to 1, right? So which means that the salary of this guy, the salary of this guy here, okay, it's much more, higher than the salary of the rest of the employees, right? So this guy would be probably the CEO of this company, right? Or the owner, the owner of this company, right? Because his salary is it's much more higher than the salaries of the other employees, right? So so in this case, so this this value here, or this class here, so this value is what I call like an exceptional value. It's very different from the other values, right? We have, it's and as you can see, there's like a gap. You have like classes with 0 frequencies, and then you have this very small class with just one as a frequency. So this value is an exceptional, very different from the other values, right? Exceptional This is an exceptional value. And that's what I call, so that's what I call an outlier. Okay. So what we are saying is, like, let's say here, your classes start at, I don't know, let's say here it's a 50K, okay? And here you have like, I don't know, let's say this is 100K, okay? But then you have, this is like, I don't know, let's say this is like 300K, right? So what we are saying is that most of the employees have their salary is like between 50K and 100K, right? But then there's a gap, and then they have the salary of the owner or the CEO, right? So yeah, so the salary of the CEO or the owner is like an exceptional value. So that's what I call outlier. Okay. Does this make sense to you guys? This notion of outlier? So that would be like a data value which is very different from the other values. So if you take a look to your homework, the exercise 2, there's like a value, the last value is like, I think 280, right? 280, right? And that value is actually, it's much more higher than all the other values, right? So that's like an exceptional, this is like the 280, that's like the exceptional, it's an exceptional data value. All right, where else? So we have the outliers. Okay, and then, so we know how to represent the frequency, how to represent relative frequency. Now the cumulative frequency. So next, so we are going to represent cumulative frequency. So using what I call ogives. Okay. So what I think there's a question in the chat. I'm sorry, I'm sorry, I missed your question, I guess. I don't understand what do you want me to do, Kimberly. Well, I mean, I hope you fix it.
I'm trying to log in on my phone, but I'm still logging to my computer. So I was,
Okay, you need like a meeting ID or something?
no, I want to switch. I want to come off the computer and go onto my phone.
You can do that. I mean, if you,
Okay.
yeah, you can do that. I mean, I don't think I need to do anything. I mean, to allow you to switch or something. I mean, that's
Okay, thank you.
all right. So what's an ogive, guys? Ogive, that's a graph. So that's a graph that display cumulative frequency. So we're gonna have like, again, we're gonna have 2 axes. So ogives are actually kind of different from histograms. So we're gonna have 2 axes. So we're gonna have like horizontal. So we're gonna have 2 axes. Okay. So on the horizontal axis, we're gonna have again our classes boundaries. Classes boundaries. And on the vertical axis, we're gonna have our cumulative frequency. Okay. So let's have an example. I'm going to show you how to graph this ogive. Example. Well, I'm gonna, you know what? I'm gonna again use the same example with the speed of the 24 cars on the highway, right? So again, I'm gonna use the same example. So we use again the example with 24, the speed of 24. The example with the speed of the 24 cars on the highway. So just again, remind you here, classes boundaries. And we're gonna need the cumulative frequency this time. Right, so again, let me see the numbers here. So we have, again, we have 42.5 to, I think, 50.5, 50.5, 8.5, 8.5, to 66.5, 74.5, 1, 2, 3, 4, still two classes. So this is 74.5 to 82, and then 82.5 to plus 8. Of course, that's 90.5. Anyway, so for cumulative frequency, we had like first class, the frequency of the first class is 1. Second class, its frequency is 0, but 0 plus 1, the frequency of the previous class, right? So 0 plus 1, that would be 1. Frequency of the third class is 1 plus the frequencies of the previous classes. So that will be 1 plus 1. So that will be 2. Frequency of the fourth class is 6. 6 plus the frequencies of previous classes, right? 6 plus 1 plus 1, or 6 plus 2, that would be 8. Fifth class, its frequency is 8 plus frequencies of previous classes. So that's 8 plus 8, that's 16. And then cumulative frequency of the last class is 24. And again, guys, I already explained these numbers last week. Okay, you can just check the notes of last week. Now, I'm gonna graph my ogive. So the goal of this example, so the question is to graph the ogive, the corresponding ogive. Okay. All right. So again, so it's the same thing here. We're gonna have like our horizontal axis with the classes boundaries. The ogive is actually different from the histogram. Okay, so the ogive, it's like a, it's like a graph of a function. We'll see in a minute. So 66.5, 74.5, 82.5, and 90.5. Right. So again, this is our classes boundaries, and then on the vertical axis, this time I'm going to have my cumulative frequency. Frequency. All right, so again, this is the intersection will be 0. And as you can see, you're going to need 1, 1, 2, 8, 16. So the highest number we're going to need is 24. So we need to go up to 24. So this is like 1, 2, you know, somewhere here is going to be 5. Somewhere here is going to be 10. Somewhere here, let's say it's going to be 15. And I need 24. So this is, let's say 20. All right. And then this one here would be 24. Okay. I mean, the shape of the graph, it doesn't have to be perfect, right? So, I mean, the units, I mean, the goal, of course, is to plot all the cumulative frequencies, right? So if you need to go to up to 24, you don't have enough space, then it's not, you don't have to have like exactly the same units each time, okay? Anyway, so now, first, to graph the ogive, first step, you need to start at the lowest, the lower boundary of the first class. So first step, so step 1. So we always start the ogive. So the starting point of the ogive is the lower boundary of the first class. Okay, that's always the starting point. So the lower boundary of the first class. Okay, so like in this example, the lower boundary of the first class is 42.5, right? That's the lower boundary of the first class. So here's my 42.5. So we need to start, you start your ogive, the first point is at 42.5. Okay, so that's where we start. Okay, next. So you start on the, you know, the horizontal axis, right? This point, this red point, right, at 42.5. Now, next point is going to represent the frequency of the first class. So this is like step 1, step 2. So next. So next point represent the frequency of the first class. Okay. So what we do, guys, is, so what's the frequency of the first class? Frequency of the first class is right here, it's 1. Cumulative frequency, sorry. Cumulative frequency of the first class is 1, right? So what we do is we go to the next class boundary, which is, you know, the next class boundary is 50.5, right? And then we represent, so we are supposed to represent the cumulative frequency of the first class, which is 1. So we're gonna go up here, you know, this point here. It's the height of this point, it's 1, which is exactly the cumulative frequency of the first class. Now we move to the next class. All right, cumulative frequency of the second class is 1 again, right? So we take the next class boundary, which is, you know, 58.5, and so we're gonna plot the point with height equal to 1, which is, again, which is the cumulative frequency of the second class. So here's my cumulative frequency of the second class. Cumulative frequency of the third class is 2, right? As you can see, it's 2. So I'm gonna do next point, which is next class boundary. You see this class boundary here? We need to go up by 2 units. So here, I'm gonna plot this point. So the height of this point is 2. That's the cumulative frequency of the third class. Fourth class, cumulative frequency is 8. So we're gonna go here, as you can see here, up to 8. So 8 here is gonna be somewhere right here. So this point represent the cumulative frequency of the fourth class. Cumulative frequency of the next class is, the fifth class is 16. So next class boundary would be at 82.5. So we're gonna go up to 16. So 16, let's say it's somewhere right here. So this point here, that will be cumulative frequency of the fifth class. And finally, we have the last class boundary, the 90.5. So here we need to go up to last cumulative frequency, which is 24. So we need to go up to 24, or 24 is right here. So that'll be my last point. So I'm gonna plot here my last point. Okay. So, and then you need to connect all these points, and that will be your ogive. So I'm gonna connect. So these lines, these vertical and horizontal lines, I'm just trying to explain. They're not part of the ogive, right? I'm just trying to explain how I plot all these points, right? So now we need to connect. So you need to connect all these points, right? So I'm gonna join. Next point will be here. Next point here, here, and then I'm gonna join this one here, etc. Okay, so this is so this is my this is the ogive of my example. That represent the cumulative frequency of my classes. Any question, guys? I mean, I know this is like a first, of course, this is just a first example. I'm gonna have more examples in a minute. But I mean, the idea again is the same. So on the horizontal axis, you have your classes boundaries. Vertical axis, this time gonna have your cumulative frequency. But now instead of rectangles, you have like a true graph. This is like a true graph, right? So you have to plot. You have to plot your cumulative frequencies, and then you need to join, the points. You know what? So let's do. I'm gonna do another example of ogive, and then I'm gonna do like another exercise. So another example. So this is example one, example or exercise. So I'm gonna give you some time to think about this exercise, all right? So let's say you have the following data or the following frequency table, which represents, let's say, the daily high temperatures, let's say during the winter in the New York City. Okay, so the following frequency table let's say represents so the daily high temperatures, let's say during winter in New York City. Okay, I'm gonna use, let's say, it's in Fahrenheit. Anyway, so we have, let's say, following classes boundaries. So of course, classes boundary represent the temperature. This is like the temperature, right, in Fahrenheit. And then you have your frequencies. Of course, the frequencies, that would be like the number of days in in a given class, right? So then you have like frequencies, and these are frequencies. So this is like the number of days in a given interval. And then, of course, we have your cumulative frequency. Okay, cumulative frequency. All right, so let's say, for example, classes, boundaries, temperatures. That's probably a good example because in the last days, I was kind of freezing outside. But anyway, so for classes boundaries, so let's say we have like 10.5 first interval between 10 Fahrenheit and 20. And then between 20 and 30. So 30.5, 40.5. Let's say we have 5 classes. So we're gonna go up to, so this is 50.5, and then 50.5, and 60.5. All right. So like in the winter, we had like, let's say 23 days, right? This is 23 days with temperature between 10.5 and 20.5. And then we have like, I don't know, 43, let's say 43 days, okay? With the temperature between 20.5 and 30.5 Fahrenheit, right? Etc. So then we had like 51 days, which is not bad, between 30 and 40. And then 27 days, between 40 and 50. But then between 50 and 60, we had only like, let's say 6 or 7 days. So only 7 days with temperature between 50 and 60, 50.5 and 60.5 Fahrenheit. Anyway, so now for cumulative frequency, so we're gonna have first frequency of the first class. Cumulative frequency of the second class would be 43 plus the 23, so that would be 66. Cumulative frequency between for the third class, so we're gonna have 51 plus the 43 plus the 23, right? That will be 117. For the fourth class, we're gonna have 144 and 151 for the cumulative frequency of the last class, right? So now, so the question is, so exercise for a question. So please try to graph the ogive of this sample data. Okay. So I'm gonna give you, let's say, so like let's say 5 minutes, guys, to think about this, how to graph this ogive. So you're gonna have 2 axes, right? There'll be a horizontal axis. On the horizontal axis, you're gonna put your classes boundaries. Vertical axis, you're gonna have your cumulative frequency, right? And then you have to plot your cumulative frequency. Let me just say here, guys, because the cumulative frequency, the numbers are kind of high. It goes to 151. So as I said, I mean, when you graph your ogive, the units, they don't have to be exactly the same. Okay, so it's like you can just let me show you here. So like so this is like your your classes boundaries. Okay, but then here vertical axis is supposed to be your cumulative frequency, right? And you're supposed to start at 0. So this is supposed to be like 0, right? So I want to put my cumulative frequencies, but as you can see, the highest, it starts at 23, right? And then the highest number is 151. So you need to put 151 on your cumulative frequency axis, right? So, you can just decide to use like, let's say 20, for example. You want to go up to 151. So you can use like 20 as a unit, like 20, 40, then 60, 80, 100, 120, and then 140, and then this is, let's say, 160. Okay. There's a question that, oh, you cannot see what my writing. You don't see the graph, or like the left side here? Is it better now, Samantha? Okay, perfect. So, I mean, in the homework or in the test, guys, when you graph your ogive, and you need to plot your cumulative frequencies. As I said, the units, they don't have to be like exactly the same. So you can just go first, check what will be your like your highest number. Okay, for example, here it's 160, right? So you need to choose like a kind of a large unit here, right? So that's why I decided to go with 20. So but if you put like 1, 2, 3, then you're gonna need a lot of space, right? uh, you know so So I'm gonna give you a couple of minutes just to try to graph this ogive. As I said, so first step, I'm gonna just remind you the steps. So of course, on the horizontal axis, you're gonna have your classes boundaries again, your classes boundaries. Right? And then, as I said, first step, the starting point, you start at the lower boundary of the first class, right? That will be your first point on the horizontal axis. All right, guys. Obviously we don't have much time, so let's solve this together. All right. And again, please unmute yourself if you have any question. Okay. Um, so I don't know if you're done with the graph, but let me just go over this again. We're gonna start with the class. I'm gonna put my class's boundaries. Of course, the first lower boundary is the 10.5, right? So I'm gonna, Yanin, you're saying the graph looks like a mountain? Yes. Yes, that's true. Um, so so the lower boundary of the first class is 10.5. Okay. So again, guys, the units, they don't have to be perfect. So you can just go with, you decide, for example, let's say this point, it's my 10.5. Okay. So I didn't really measure any units here, right? Okay. So you just decide, you take a point which is kind of close to 0, and that will be like your lower boundary of the first class. Okay. So your units, they don't have to be perfect. You can just decide, like, take a point kind of close to the 0, and that will be your lower boundary of the first class. Okay, so here 10.5 kind of close to 0. That will be the lower boundary of my first class. Okay, I didn't measure any units here. And then next class boundary is 20.5, right? So we have like 20.5, this is like 20.5, then 30.5, and of course distance between like 10.5, 10, 20.5, 30.5. I mean, the distance is supposed to be the width, right? They have all the same distance. Between, let's say, 10.5 and 20.5, the distance is 10, right? 10 units. Between 20.5 and 30.5, that's 10 units, etc. You don't really measure 10 units, right? You just take the same, more or less the same, the same length, right? So this, let's say, would be my 40.5. Then I have my 50.5, and then taking just the same length each time, right? So this would be my, I'm sorry. This would be my 60.5. All right, so then we said the starting point is always the lower boundary of the first class, right? This is my starting point. So you always start from on the horizontal axis, okay? The starting point is always on the horizontal axis. And it's gonna be at the lower boundary of the first class. Okay. All right. So that's my starting point. Now, next point. The next boundary would be the 20.5, right? That's my next boundary. Now, the next boundary is supposed to represent my first cumulative frequency. My first cumulative frequency is 23, right? As you can see here, 23 is my first cumulative frequency. So I'm gonna take my boundary at 20.5, and we're gonna go up to 23, all right? So we're gonna go up here. Let's say this is 23. And so this would be the cumulative frequency of the first class, right? This is my 23. And again, the 23 here, it's just a kind of approximation, right? This 23 is not really, again, didn't measure any units. This is kind of like an approximation, right? Now, next frequency, or cumulative frequency, sorry. It's 66, right? So I'm gonna take my next boundary, which is 30.5, right? This is my next boundary, 30.5, and I'm gonna go up to 66. So I'm gonna plot this point here up to 66. 66 is, it's obviously between 60 and 80. So it's gonna be somewhere here. Let's say this is like my 66. And I'm gonna get my the cumulative frequency of my second class. Right, third class, we need to go up to 117. So 117, it's kind of close to 120. So here's my 117. I'm gonna take my next boundary, class boundary, which is 40.5, and we're gonna go up here to 117. Next, it's 144. So I'm gonna take my my next boundary, class boundary, which is 50.5, and we're gonna go to 144. So here's 144. Okay, so we're gonna go up here to 144, and I'm gonna plot my point, my cumulative frequency of the fourth class, and now the last class, the cumulative frequency is 151. So that will be the last boundary, class boundary, which is at 60.5, and we're gonna go up to 151. So 151, it's more than, of course, it's larger than 144. So it's gonna be somewhere here, let's say, and this is 60.5. So we're gonna go up to 151. And so I'm gonna plot my cumulative frequency right here. Okay. Again, guys, the vertical and the horizontal lines, they are not included in the graph, right? I'm just using them to explain how I plot all these points, right? So this is not, they are not included in my, in my OJI. I'm gonna just erase those horizontal and vertical lines. Okay, so I have these points, and now I need to join them, right? I'm gonna join these points. So this is, oops, sorry. This is my starting point right here. So I'm gonna join these points now. Go up here, and up here. Right, so this would be my the ogive of my example. Any question, guys? All right. So what I'm gonna do now, we're gonna do an example which covers like the histograms, shape of histograms, ogive, everything. So let's have the following exercise. I don't know if I'm gonna have time to go over this exercise today, but I guess probably it would be a good idea for you to finish this exercise at home. And so on Wednesday, well, I'm not sure if I'm gonna go over this, but we'll see. Okay. So in this exercise, so we're gonna have the histograms, ogive, everything. Okay. So let's say we have a college. So a college department. Let's say recorded the number of students with the grade, number of students receiving a grade A, or A plus, uh, um, in the last fall semester. Or let's say in the last 16, I'm gonna take 16 semesters actually in the last 16 semesters. So let's say, for example, so I'm gonna order the number of students using grade A in the last 16 semesters, from the lowest to the highest. So I'm gonna order them. So we have the following. Oops. So we have the following. Values ordered from the lowest to the highest. Okay. So this is again from the last 16 semesters. So there's one semester we had, let's say in the department, only 9 students with a grade A. And then another semester with 32 students with receiving grade A. Let's say then we have, let's say 35 students, 39. So it's a 16 semesters. So we're gonna have 16 data values, right? So 35, 39, 42. There's another semester with 46 students receiving A, 47, 48, 48, then 53. Another semester with 56 students receiving grade A, 57, 58, then 59, and the best semester in the last 16 ones, we got 65 students receiving an A. All right, so first, what we're gonna do, we're gonna make, so first, we're gonna make a frequency table with 5 classes. So let's say 5 classes. And this frequency table, let's say, it doesn't include everything, okay? We're gonna need just probably the classes boundaries, limits. So showing, make frequency table with 5 classes, showing, let's say, what we need, actually. So classes, limits, classes, boundaries. And then we're gonna need frequencies, of course. Frequencies, and then cumulative frequency. Okay, so again, in this frequency table, guys, you don't have to include everything, right? Just we need the, as you can see, we need the classes limits, we need classes boundaries, frequency, and cumulative frequency. Okay, again, this is for the purpose of this exercise. All right, and then so we're gonna draw the corresponding histogram to. So we need to draw the corresponding histogram showing, let's say, frequency histogram showing frequency of students receiving A. Receiving A. So we need to draw the corresponding histogram. Now, next, we need to describe the shape. Describe the shape. Okay. 4. So 1, 2, 3, 4. Are they any exceptional values or outliers? Okay. 5. So which class has, or which interval has, or class has the highest, so which class has the highest frequency? Is the highest okay. And 6, we need to graph the corresponding ogive. 6, graph the corresponding ogive. All right, guys. Okay, so how many questions? 6. Okay, that's enough, I guess, for the moment. How much time do we have? Oh, 2 minutes. Okay. All right. Well, time really goes really fast. So, you know what, guys? Because this is kind of an important exercise because it covers a lot of things. So I think I'm gonna go over this probably next time. Okay. But it would be a good idea if you try to do this at home. Okay, because this would be a really good exercise, like in a test or in the homework. So that would be probably good. It would be a good practice. Um, are there any questions, guys, about I mean, these questions? I mean, do you think it's more or less clear how to answer all these questions? Uh, again, for the outliers here, this is like the exceptional value, right? A number which is very different from the other numbers. Okay. What I mean by different, I mean like it's a number which is much higher than the other numbers. Okay, or much lower than the other numbers. Okay. Yeah, I mean, I guess probably you can just follow the examples that we had today, and you can probably answer all these questions here, right? All right, guys. Yeah, so I'm probably gonna stop here. I'm gonna go over this next time. And I mean, this exercise will be probably your first exercise in the test. Of course, different numbers, but that's like the idea, right? Yeah, so again, tomorrow follows Friday schedule, so hopefully I'm gonna see you on Wednesday. All right. Thank you for listening, everyone. And I will see you on Wednesday.
Right, thank you.
Have a
for-
good day.
Thank you,
Bye.
Professor. Thank
Bye,
you.
have a good day, everyone.
Professor,
Yes.
our
Yes.
next class is on Wednesday, right?
Yes. We're gonna
Okay.
meet on Wednesday. Yes.
Okay, thank you.